and welcome back to Teacher Gimble's channel. Today we're going over Illustrative Math, Algebra 1, Unit 1, Lesson 5, Practice. If you like this video, please make sure to like and subscribe. I think you can hit the button that's right there, and I'm looking forward to seeing you in other ones. Let's get started. Problem 1. Match each sequence with one of the definitions. Note that only part of the definition is given, showing the relationship between the current term and previous term is given so as to not give away the solutions. So I think the hardest part of these problems is notation. So let's talk about notation. When we refer to n is counting numbers, usually. So the counting numbers, or the integers, they're going to refer to the place in the sequence. So if I have n equals 1, that means I want the first term in the sequence. N equals 2, the second term, n equals 3, the next terms. Now we're going to have this thing, which is a function, which is a of n. This over here is going to be the value of the nth term. So let's look at this right here. If we're going to play a little bit of match. So I have a 6 and I have a 12. So a to the n, let's call this 12, is going to be equal to 7 times a to the n minus 1, which just means the term that comes before the 12, which equals 6. Does 12 equal 7 times 6? Nope. So we know 1 and a don't match. So let's do another one. The more practice you get, so a to the n minus 1 is equal to the previous term. And it's the term that comes behind whatever nth term we're thinking of. Let's try to see if this works with b. We're going to call a to the n 14 because it's the second term. The previous term is a to the n minus 1. Well, the previous term in this case is going to be 2. Does 14 equal 7 times 2? Yeah. So that looks good so far. Let's go ahead and check another one of our questions. We have 98 is going to be our term. Is that equal to 7 times the previous term? The previous term is 14. 14 times 98, do a little bit of mental math, is 14. 7 times 14 is 98 with the mental math. So we're going to say 1. B is going to be 1. Let's go ahead and check 2. So we have b to the n is one of our terms. Now let's say 18. This should be equal to 1/2 whatever our previous term was, because that's what b to the b of n minus 1 is. 1/2 times 12 is 6. So that does not equal 18, which means we're very likely this is going to be our correct answer. So let's use one of our terms. 40 should be equal to 1/2 times the previous term, which is 80, which is true. So we're going to say this one is equal to 2, which leaves us with a to be matched with c, but let's double check to make sure we're correct. We have 18, or even let's do 24. We can do any of our terms. 24 needs to equal the previous term, which is 18 plus 6. That's true. This one is equal to 3. And we're done. So the most difficult part of this is decoding the notation. But once you've decoded the notation, these questions should be pretty straightforward. All right, so pause if you need a second to think over it, but we're going on to the next question. Write the first 5 terms of each sequence. Determine whether the sequence is arithmetic, geometric, or neither. So we have a to the first. So let's do number 1 right here. The first term of the sequence is going to be 7. Okay, that was easy. The next term of the sequence is a to the n is equal a to the n minus 1 minus 3. So the next term, so we're going to figure out the next term, which is a to the n. This is going to equal the one before it. So the one before it in this case, because I'm looking for this dude over here, is 7 minus 3, which gives me 4. So my second term is going to be 4. Don't worry, we're going to do this several times in case you need help. So we figured out the first 2 terms. The next term in our sequence, so we're looking for the third term in our sequence, is going to be the one before it, which is 4 minus 3. Okay, that's 1. And now we can do the next few in our head. The one before it, which is 3, minus 3 gets you negative 2. The one before this upcoming term is negative 2 minus 3 gives you negative 5. And because we're subtracting a constant amount, then that means that we are an arithmetic sequence. Let's go on to the next one, number 2. b of 1 is equal to 2. So our first term is a 2. And then the next term is going to be 2 times the previous term. So 2 times the previous term, that's going to be 4. 2 times the previous term here is going to be 8. 2 times the previous term, 16, 32. And we're multiplying by a constant number, which makes it a geometric sequence. All right, number 3. Our first term is a 3. Each next term is 10 times the previous term. Okay, 30, 300, 3,000, 30,000. There we go. We're done. And again, that's a geometric term because we're multiplying by a constant number. Now let's check this one out. Our first term is 1. The next term is going to equal whatever place value that term is minus times the previous term. So this over here, this is the second. This guy was going to be the third. This is going to be the fourth. This is going to be the fifth. So in this case, for the second term, it's going to be 2 times the previous term, which is 2. For the third term, n is 3 times the previous term, which is 2, which gets us 6. The fourth term is going to be n, so the fourth term is 4 times the previous term, which is 6, which is 24. And then the fifth term is 5, because we're talking about the fifth term, times the previous term, which is 24. And 5 times 24 is 120, I think. Double check that in your calculators. And in this case, because we're not using a constant value of multiplying or dividing, and we're not doing a constant value of adding or subtracting, it is neither a geometric or an arithmetic sequence. So take a second if you need to go over this and think about it, because we're moving on to the next question. The first 5 terms of some sequences are given. State a rule that each sequence could follow. Well, here we have our first term, plus 2, plus 2, plus 2, plus 2. So we're going to say, our first term, a to the n, is equal to, well, we're not going to say a to the n because we want just our first term. A to the 1 is equal to 2 because that's our first term. And a to the n is going to equal to a to the n minus 1 plus 2 because it's a previous term plus 2. We're done. This one, 5, 7, 9, 11, same thing, except a to the 1 is equal to 5. Now we have a to the n is equal to a to the n minus 1 plus 5. It's going to be the previous term plus 5. Here I'm seeing 50, 25, 0, negative 25, negative 50. So I see that I'm subtracting 25 from each one. So my first term, a to the 1, I'm going to put as 50. And I'm going to say each next term is going to be the previous term minus 25. Now our last one, we have 1, 1 third, 1, 3, 9, 27. I see that I'm multiplying by 3 each time. And if you have a hard time seeing what these patterns are, then you should kind of practice some of your mental math with addition and subtraction to start seeing these patterns a little bit easier, which means a to the n is going to be the previous term. And I'm going to put this all in parentheses, times 3. And that would be a geometric sequence. All right, so we just stated a rule each sequence could follow. Let's move on to the next question. Ooh, I don't want to buy now. Delete. Problem 4. Function f is defined by f of x is equal to 2x minus 7, and g is defined by g of x is equal 5 to the x power. Find f of 3, f of 2, f of 1, f of 0, and f of negative 1. Oof. Let's make a table. F of 1, delete. We want f of 1, f of 2, f of negative 1, f of 0, f of 3. I did not put those in order. And all we're going to do is we're going to replace our x value for whatever's in parentheses here. So 2 times 1 is 2, minus 7 is going to get us negative 5. 2 times 2 is 4. Minus 7 is going to get us negative 3. 2 times negative 1 is negative 2. Minus 7 gets us negative 9. 2 times 0 is 0. Minus 7 gets us negative 7. 2 times 3 minus 7 is 6. Minus 7 gets us negative 1. And we're done. I like to put it in a table just because visually that helps me understand it a little better. Let's go ahead and find our g's. So we have g of 3, g of 2, g of 1, g of 0, and g of negative 1. And our rule is g of x is equal to 5 to the x power. So this is going to be 5 to the third. 5 times 5 is 25, times another 5 is 125. This is going to be 5 to the second, which is 25. This is going to be 5 to the first, which is 5. 5 to the 0, which is 1. And 5 to the negative first power, which you'll learn about this later, is 1 over 5. And we're done. That was it. Let's go on to the next question. Problem 5. Here's a graph of two sequences. So we've got a graph, we've got the triangles that represent one of our sequences, and we have the black dots that represent our other sequence. Complete the table for each sequence. Okay, well, let's go ahead and see what we've got. We have term number. So for 0, sequence A is negative 1, and sequence B is 1/2. So I see that negative 1 is the blue triangle, so I'm at sequence A is that line. It also says sequence A now that I see it. So the second term here is 2. The next term, our first term, our 0th term is negative 1. Our first term is 1. The second term is going to be 5. And we have 8, 11, 14, 17. And I'm seeing over here that we're adding 3 to each one. So I'm just going to put a note of that because when I see a pattern, I like to take note of it. Now, sequence B, we start at 1/2. We go to 1, then to 2, then to 4, 8, and 16. Wait, I missed one? No, 16 is the 5th. And I think the next one's going to be 32. Why is that? Because I see that we're multiplying by 2 for each one. So for sequence A, describe a way to produce a new term from the previous term. So we could say add 1, or we could say a to the n is going to be a to the n minus 1 plus 2. For sequence B, describe a way to produce a new term from the previous term. So we could say multiply by 2, but we're mathematicians now, so we're going to say a to the n is equal to the previous term times 2. And this should be plus 3 because our constant was 3. Which of these is a geometric sequence? Well, which of these uses multiplication? Ding, ding, ding. Which of these is a curvy dude? Ding, ding, ding. Those are 2 ways to figure out if it's a geometric sequence. All right, if you have any questions, please put them in the comments below. And if you would like to subscribe to this video so you can keep getting more like this, let me hit the subscribe button. That's in one of these corners. And I will see you next time.